Hi again, everybody. Welcome back. We're in week 3, and I'm saying that kind of for me because I'm not in week 3 right now, but we are in week 3 right now. Hope everything's going well. I guess on the administrative side of things, the thing that we need to worry about, kind of most notably, well, hopefully the weekly exercises are happening for you, and forming groups needs to be done by the end of this week. So in the next couple of days for the technology evaluation, get your groups figured out. Well, for the technology evaluation and project. And then the first thing that's due for groups is you need to choose topics for the technology evaluation. So you send me an ordered list of those, most to least favorite, I guess. Pick the subset of these that is interesting to you, and you don't have to get the perfect thing. You might accidentally learn something. That's okay. Okay, so let's have a lecture. So the place we left off last week, we were talking about web servers, and so again, there's this thing that is running on the server side that responds to requests. There's two sort of different categories of things that can happen that the web server has to deal with and has to be configured to deal with. One is static content, so just there's a file, find the file, send it out. Or dynamic content, there's a program, one way or another, run the program, grab its response or whatever it generates in the right format, send that to the user. The user doesn't necessarily know which one's which, but you have to figure it out as a developer, I guess. So I think this is where we were. I see this a lot, and I get it, right? So you're a computer science student or similar. Probably you're thinking about programming when you're thinking about designing a web thing. And I see developers do this where they say, oh, I need my site to go fast. I'm going to do all of these tweaks to my Node.js or to my Ruby on Rails or to my PHP or whatever it is, without realizing that their site isn't slow because of their couple lines of PHP code. The site is slow because they're downloading all of these huge static resources. So even if, on any website, don't forget that just because you think of your site as dynamic because you're writing code that generates it, a lot of what's actually happening is still going to be static resources. So just keep that in mind. And as I start talking about page speed later tonight, we'll see some more of that. Another thing that, again, I mentioned last week, I don't think I really quite had it on a slide. There's this possibility that the web server the user sees, so the user's in a browser, they go to whatever web server. What might happen is that that's just like a front-end web server, a load balancer or front-end server or whatever you sort of call that thing. It's just sort of acting as traffic cop. What it does, get a request from the user and send it back to one of 100, for all I know, backend web servers that are running the Ruby on Rails code. So maybe the one that the user sees, the one that's running Nginx or whatever, is doing a fairly stupid job. And then there's more servers that are doing the application work back behind the scenes. And we'll be seeing that happen. So this concept of having a dynamically generated page requires programming, right? You need a program for that. And in general, back-end programming or server-side programming, in contrast to the thing happening in the web browser, the JavaScript or client-side or front-end programming. And this is at least half of the story for that technology evaluation. So in these topics, there are a bunch of tools that are sort of helpful on the server side, things that run on the server in Python and Ruby and PHP and possibly Haskell, Java and Java JVM things. You have your choice of language back there. And the other half of this are the front end tools, the things that are JavaScript mostly and run in the web browser. Well, run in the web browser, usually that means JavaScript. So I'm going to talk a little bit about server-side programming here. And I'm going to talk about it in like the most old-fashioned way possible, just because why not? You can see all the bits and pieces here. So a CGI script is like the first, as far as I remember, way to generate dynamic code on the server side, dynamic responses on the server side. It's basically any program, like anything you can run on the server, usually a Unix or Linux server. And it's not fast, and it's not fast for a couple of reasons, but this is a complete CGI script written in Python. I have to make it executable. And then this just prints. And I guess if you haven't seen Python before, I think we can all guess what this does. Print this line, print a blank line, print this and this and this, obviously HTML content. And this probably looks familiar. This is exactly the sort of end of the HTTP headers. So I have produced one. I could produce more HTTP headers that go straight into the response. I've produced the blank line that sits between the headers and the message body of the 200 OK response. And then I produced the message body, the HTML page, because I've said it's HTML content. And that's it. Again, in some sense, I'm done here. This is kind of everything you need to know about server-side programming. Something happens, a program runs, and it generates a response. Probably not this way. Part of the reason this is slow is every time I want to generate a response, I have to start this program up, start the Python interpreter, start a new process, parse the code, all of that stuff. Then there's just a bunch of extra work to do there. Every single time a request comes in. So maybe this isn't the way to run Google or whatever, or there's also a lot of software engineering that could be saved. Like I don't want to write every single line of every single response myself. I want somebody to help me with that. But this is the idea. So if I want to make this run, I copy and paste this, I put it in a something.py file, put it on my web server, somehow configure my web server that so when a certain kind of request comes in, it knows that it should run this and capture the output and treat it like a CGI script. And I don't remember how to do that because I don't tend to write CGI scripts anymore. I'm sure there's, some documentation somewhere. So for any server-side program, the input is basically the request came in. So the request came in with a path and with some HTTP headers, and that included, like if it was a post request, the message body with a form submission, or as a GET request, maybe a query string with a form submission. Again, the path, like, whatever the path part of the URL is, that kind of is there as input. And what I have to produce is a response, okay, one way or another. In the CGI script, I just sort of print to standard out. In some other tool, I as a programmer, I generate some HTTP response object, and some other bit of code in the middle turns that into bytes that go towards the user. And after that, program. So like in between, okay, I can get input, which is the path and headers and whatever else. I can produce output. Well, anything I can do in any other program, now I can do that. And often that might be, go to the database and say, well, I've got this URL from the user. They want this record. Find that record in the database, build the right HTML, send it out. And those things are the common problems. Getting data from a database. So we've all taken a databases course to get here. So you presumably know how to do that. It's not exciting. It's something that you probably know how to do, and you've written it a few times. You don't want to write it 1,000 times on 1,000 different, in 1,000 different spots. You want to make that as easy as possible on yourself so you can get on to other stuff. That connecting URLs, that thing I said, which is this URL was requested by the user. URLs that are in that shape are handled by that function. That's fine. Again, like if the URL looks like this, call that function is easy code to write, but again, it's boring. Hopefully somebody else can make that easy for me. And I said, okay, we're going to generate HTML. How do I take this blog post and turn it into HTML? Well, again, all of us have to do this. We don't all want to write that code every time we need it. This is where the frameworks come in. And again, all those things that were on that page, the Ruby on Rails and Django and Play and ESOD and increasingly obscure things, if I go down the list far enough, they're all fundamentally on the server side helping with these things and a bunch more. And like I said, the technology evaluation, we're going to hear about those. So the whole point of having these presentations that are the semester video presentations is I want you, and I think it's genuinely useful, to sort of go through to see a survey of these. You've heard of, I don't know, one of these or two of these or whatever. Why would you choose that one, or why would you choose the other one? This is often, it's interesting for me to hear sort of different groups explain these topics, and some I know fairly well, some I really have never written a line of code in. The TA is often, like, this is often one of the bonuses of TAing this course for them, that they get this like tutorial on a whole bunch of different web technologies, and we pay them to market, which is a nice little side benefit for them. So again, they're better, they're worse, none of them are perfect. Since I'm thinking about it, this is the point of that presentation, especially, is tell us, me and the TA and all your classmates, what is it? So, if your technology is Snap, what does Snap do that's interesting? If I'm a developer, why would I choose it or not choose it? Help me out. Help me make that choice. And of course, if there was a right choice, if the answer was always choose Snap or never choose Snap, none of this would make sense. So the answer is going to be sometimes. Okay. This isn't really, I don't think, part of this course, but it is part of this course. I've said here, oh yeah, you generate some HTML and you send it to the user by HTTP. That's easy to say and wrong. Networks, I don't have a network cable in front of me. Imagine I hold up a network cable. That cable doesn't send characters, it doesn't send HTML, it sends bits. Whatever you're sending over it, it's a JPEG image, it's a movie, it's a HTML, has to be turned into bits to go over the wire or the Wi-Fi. Oh, I do have Wi-Fi. The Wi-Fi is carrying bits. So if you get it wrong, if somehow you turn characters, like I think of HTML as being made of characters, and if you get that wrong, and I don't know if I can, like, there we go. If you get it wrong, you end up with this kind of thing where this is obviously not what the user typed. John Boehner, did not type binge that a euro sign trademark s. He probably typed that's with an apostrophe. This is what happens when you get the characters wrong. So at this point, if we were in a room together, I would look at you and say, how many of you are really comfortable that you know the difference between character sets and character encodings? And experience tells me that like one or two people would cautiously put up their hand and as if to say, I think I know the difference, but I also think this might be a trick question. And most people would try to avoid eye contact. And this is why it becomes part of the course. I do want to explain this because it's important. It's important to the web. It's important to just programming and computers in general. But experience tells me people get here and don't have this in their head. Okay, characters. Here's one, right? Like the capital letter A is a character. So is a lowercase a. They're different characters. I can tell because they're different. A character set is a collection of those. So every character that we want to have in our text document, numbered. So somebody at some point decided, okay, we're going to need this thing called capital letter A in computers. We're going to number it, and it got number 65, and lowercase a got number 97. And at some point, somebody decided, oh, the subset or equal to symbol needs to be there. It got 8,838. And somebody at some point decided, oh, you know what, there's this Chinese character for possibly happiness, if I remember properly, and it got that number. And even later, somebody said, oh, you know what we absolutely need in computers is poo emojis, and it got that number. So, okay, character set is just that. All the characters we need, numbers to sort of, so we can say character number 97 is this. No bits yet. And there's a bit of a historical story arc here, and it was, in the 70s possibly, and before there were computers before this, nobody ever really if you don't exchange information between different computers, every computer can kind of do this differently, and who cares? At some point, the world realized, ooh, computers share information, don't they? I want to take a file that was created on an Apple computer and copy it over to the Commodore 64. We have to agree on how those characters are represented. And that story I just told, I guess, was at the early 1980s. So it happened before that. But what was happening in the 70s was, well, computers were happening mostly in the United States and England, where English is the language at hand. So if you happen to have, I don't have the camera pointing at my keyboard here. Looking at my standard like English keyboard, if I start counting, okay, there's A to Z, uppercase and lowercase, and digits 0 through 9, and the like exclamation mark, at, number sign. If I add all those up, I'm pretty sure I get 95. Okay, I'm not going to count them right now. Pretty sure it's 95, and 32 is space, and 126 is possibly the tilde or something, and all the way in between. I swear I checked that link. Anyway, fine, ASCIItable.com. Why not? Oh, I know why not, because they've encoded it as a damn image. The modern web sucks. Anyway, here's one. Okay, so, right, the capital letter A, it looks like that. Like I said, it was character 65. These are that sort of first wave of characters. And then, the world being what it was at the time, the people in the United States and England looked across like the English Channel and thought, oh geez, those people over there, they have these like vowels with stuff on them, right? So over there in France, they don't just have the letter E, they have E with the little thing on it and E with the other little thing on it. Okay, fine. Well, okay, we'll number those, and character number 136 will be the E with the hat on it, whatever hat is called. It's been a while since French. And then, at some point, they looked a little farther across Europe, and they're like, crap, Greek people have their own alphabet. And it says, okay, we're out. And at the time, there was the idea that, okay, we'll put all of this in one byte. So if you can only have 256 characters, you kind of can't do all of these at the same time, but you can do any one of them. So we had that, and as long as a Greek person never wants to send a text file to someone who speaks Hebrew, everything's fine. But it wasn't, because sometimes people want to do that, and then it turns out there's more to the world, and they looked farther and realized, oh, there's Chinese and Japanese people, and that's not going to fit in a byte, no matter what we do. And then, we want the poo emoji, and we want the happy, 28 happy faces and everything else. Okay, we need a big character set. And this is where Unicode comes from. It's this sort of classic, like, we had a way to do it first. And then we had, we kind of patched that up to try to make it work for a long time. We realized it wasn't working. Okay, everybody stop. Let's do this right. Let's redesign everything, because now we know what the real requirements are. And the requirements are something in the 130,000 character range. That's what it takes for all of the languages that we all want to write down. And this unicodetable.com, if I can get a decent font size here, is a very long page to scroll down. And at some point, I don't know if anybody here reads or writes Tibetan, but oh boy, apparently increasing the font size was a bad idea. Or what are we? Oh, Cyrillic. So all of these are there, and as you scroll, if you scroll, I feel like if you scroll to a random place, there's a very high probability it's a Chinese, Japanese, Korean alphabet. But all of these things are in here somewhere. Again, my written Sudanese is a little rusty, but there you go. If I need to communicate those characters, there they are. I can copy and paste them at the very least, even if I don't have them on my keyboard. You may take a moment. This is well worth it. Joel Spolsky's absolute minimum every software developer absolutely positively must know about Unicode and character sets, no excuses, is a good read. It's worth it. Yes, you should know about Unicode and character sets, no excuses. Because frankly, this is text, right? Like, you don't want to write a system where, capital letter C is a character, but Greek letter aleph, Hebrew letter aleph is not. And that funny symbol that comes up on Apple computers, well, you should be able to put that in a file too. So this is unavoidable. What Unicode defines so far in the story is a character set, just 130,000 or so numbered characters. A character encoding is where we face the fact that we have to convert that thing to bits. To send it over the wire, to store it in a file or whatever, I have to take this ideal of there's something called capital letter A and it's character 65, and I have to make bits out of it. So when you have sort of a small number of characters, less than 256, one character just encoded as the number encoded as a byte, and that's easy, and that was easy until we had more than 256 characters to worry about. At 130,000, well, we have some questions to answer here. One thing we could do is just say, well, okay, let's take 4 bytes per character. Every character is going to take 4 bytes. That's 2 to the 32 possible characters. That's a big number. But, well, most of my text, I don't really want to take 4 bytes per character. Like, if I look at, say, this web page, even if this web page was in Greek or something, all of these characters would be unchanged, right? All the HTML, the CSS is all straight up ASCII characters until I get to the actual text that is like visible to the user. Then I might change languages. So I'm going to have a lot of ASCII text. I really don't want to spend 4 bytes to transmit every one of those. And I can cut the story short here because this is a web course. There is an answer, and the answer is UTF-8. All text is Unicode text and encoded as UTF-8 in this world, or should be. I always feel like and in fact, increasingly is. So this is what encoding is used on the web. And back in the early days, even of the web, most web pages were sort of assuming, well, this is an English page, I'm only communicating with English people, so ASCII's fine. And apparently, I don't know, something happened in the late 2000s to all of a sudden UTF-8 is the thing that you should encode text as, and everything else is just increasingly rounding error. If you ever wanted, it's just beautiful design. My God, like if I was going to design a way to encode Unicode characters as bytes, I would have done something much uglier than this. And the short summary here is characters take either 1, 2, 3, or 4 bytes. ASCII characters take 1 byte. So the ASCII text that is, less than HTML greater than, still 1 byte per character. Nice. I don't have to transmit a lot of bytes, but I have enough room to encode up to whatever that is converted from hex to decimal characters. And that's nice. Unicode text gets encoded as UTF-8. That's the short answer here. The slightly longer answer is there are still other encodings out there that developers might use that the web browsers have to understand. That's why this has been part of our HTML template. In fact, the validator demands a meta charset element in your HTML just to say good and out loud, I am encoding my text as UTF-8. I know, and now the browser knows. We agree. You can say it in CSS as well. It's not as common to see that just because I think it's probably assumed, and most people are pretty good at that. You can also say it in an HTTP header. There's this parameter on the content type value where you can say at that level, like even before the browser ever sees the HTML content, you can say, yeah, it's encoded in UTF-8, just so you know. And of course, you have to then get that right. So if you have this, like whatever I had in this last example, and like you probably can't, the font size is too small, and I don't think I can increase it. But there is this little thing down here of what encoding do you want? And it was UTF-8 by default, and I didn't change it. I could have, I probably shouldn't. So I guess the assumption there is all text is Unicode. The question for the person using that text editor is, how did you want me to encode it? As a developer, outside this class, as someone who writes programs, there is no such thing, there should be no such thing as a default character set. Hey, I have a text file. I'm just going to assume it's some character set is not something you should ever do. You should know what character set it is. You should be explicit. Like if you're producing a text file, you're not producing a text file. You're producing a UTF-8 encoded text file or a UTF-16 or whatever. The encoding is part of the sort of description of that file. On the other side, when you're reading a file, and I bet you've done this, I bet in some course you were told, read this file, it's a text file, and something with the contents. You didn't say what character encoding that file was. In most languages, there's a default. You probably shouldn't have accepted that default, or you should have at least thought about, well, what encoding is going to be used here? Is that right? If you're a C programmer, especially, this assumption is really easy to make because there's a built-in type in C that's been there since the days when only English existed in computers. There's this type, char, however you want to pronounce it, that doesn't hold a character. That type holds a byte. It's named wrong or named with an assumption. If you have a character, what you need is, the wchar type that holds a Unicode character, effectively. Be careful with this, and it's what happens back here, right? So the reason that this thing got to be this way, we're not usually writing code that's going to have stuff hanging out behind a president, but this is what happened, right? So this was the string. This is, I'm just writing some Python here. This is the most extended version of a Unicode literal. So let write single quote s, which looks like that. Right, so that's the string that was in the original text that was in the tweet. That's the text that was sort of in Twitter's database. This is almost certainly the sequence of bytes that was sent from whatever to the program that generated this backdrop behind Obama. That program assumed, probably implicitly, right? It was probably opened the file, read the text file, and just kind of threw it on the screen somehow without thinking about what character encoding it was. Probably it was the default in a Windows system or something. And when you take these bytes and you decode them with a different character set, you get that. And that's exactly what you sort of see on the screen here. So don't do that. Every time you touch a file or any kind of bytes from the user, HTTP request, whatever it is, you have to have that neuron in the back of your head that fires and asks, hey, what character set was that? What character encoding was it? Better make sure. Someone should have explained this to you long ago, but experience tells me they didn't. Hopefully that helps. Encodings matter. And it's not hard. At least in most, sort of nice modern languages, it's pretty easy. So in Python, what's happening here is this is a string. A string holds characters. This is a byte string that holds bytes. Encoding into a character set turns it into bytes. Decoding from a character set turns the bytes into characters. So there's these two opposite direction operations. It makes sense to encode a string. It makes sense to decode bytes into a string. And when you say open a file, there's an argument for what encoding. There's a default, and you shouldn't accept the default. You should kind of say it. Anyway. That's why we've got this in all of our code. And why, again, you should have a little thing in the back of your mind. Okay. Something else we saw in HTTP as we were talking about status codes were these redirect codes. Well, redirect plus the other one. So in the 300 range, these permanent, temporary, and see other redirects, and then the 410 gone. All of which, again, like have subtly different semantics, but the same kind of idea that this URL is somewhere else now or isn't anywhere else now. They come with a friend, and the friend is a location header. So when this gets sent, so every time there's a 301 response, it comes with this location header. What the browser does is automatically bounce to here. So the user doesn't have to do anything, click on a link. You know, if you ever see like, hey, we've reorganized our site, click here. This is an author that didn't know, or a tool that did allow the author to access a redirect. And like I can prove to you that these work. I guess I can do it, well, I'll do it here. So if I take the URL for the course slides, if it's this, if I take that slash off and I hit enter, this slash magically reappears. And the reason for that was when the server saw this request come in, it came back right away with 301 moved permanently to the same URL with the slash appended. And that's something that the web server does, I guess. And actually, maybe I'll show the whole thing. There is a little like stub of an HTML page generated there, which you've never seen. Like users don't ever really see this because the browser automatically deals with the redirect. If I go to, well, if I was in a web browser, what would happen next is the browser automatically fetches the location URL, and you get the actual thing, the 200 OK, and actual HTML comes out. So this has been happening in your life and every user of the web's life all the way along, whether you noticed or not. So sometimes you need to produce these just as part of making a web thing. And now there's two choices. And again, there's that sort of static and dynamic content distinction. For static content especially, or if you have these big redirects, it's probably easier to just set up your web server to do it. So in Nginx, there's this rewrite directive, and there's a few examples here somewhere. I always find the syntax of these is somehow just that little bit more complex than it needs to be, but I'm sure there's a good reason. So if a URL comes in that matches that pattern, redirect the user to here. With a 403. Maybe that's not a status code. Anyway, whatever it is, URLs that look like this, the user gets redirected to the URL that looks like that. And I think that's a substitution. So it's like the URL is download/something. The download/something gets, I think, substituted in there. So that's great for something that's big, like you want to always send the user from the non-encrypted to the encrypted version of your site, or you have static content in some directory and you just had to reorganize your site to rename the directory, or you have a static file and, well, there's no other place to sort of inject that. If you need to redirect it, it has to be at the server because it's the only thing that deals with static files. If you have more dynamic stuff, maybe you can make your web server do it. Maybe it's easier to do it as a programmer as opposed to someone writing a configuration file. So like I talked last week about the post redirect get pattern. If as a user type some stuff into a form that actually gets saved, causes a side effect. So I want it to be a post request, but I want the user to be looking at a get request. So when that form gets submitted, this kind of thing happens. So the request comes in. The logic that I wrote as a programmer says, well, if it was a post request, I'm going to deal with that. I will probably, what's hidden there is process the form, make sure it's valid, whatever else, like construct the object, save it. So actually have the side effect happen, and return some kind of redirect to some URL. So that's the post redirect part of the pattern. The user gets the redirect. Presumably the place I sent them, is capable of dealing with that get response, get request. Maybe something like this, where there's a pattern of URLs. Like there's the old place that I allowed users to get details of items for sale or whatever. They used to be at this URL. I need to move them. I've had to reorganize my site because there was some collision between different URLs. If anybody hits the old details view URL, I'll give back a redirect to whatever the new version is, like whatever URL I need to put there as that argument. And okay, that can be there. Every server-side framework has some version of this. You should make sure you kind of know where it is. And now the whole world of programming opens up. Right, so we can do the post redirect get pattern by just recognizing I'm dealing with a post. I will respond with a redirect. Generally, logging into a system is like this: that you hit a URL, and the logic on the server is they have to log in and they're not logged in. So send a temporary redirect. It's only temporary until they log in. That says, okay, you were here. I'm going to ship you over to the login page, probably with some query string that is like a return address. After the login, temporary redirect back to the page you actually wanted. There could be a case where you have like a record in your database that is marked deleted. And I mean, general advice from me is don't, unless you have a really good reason, don't delete rows from your database. Have a field in your database that's something like is deleted that has a Boolean. So, and one of the reasons is you can do this trick. The other reason is people sometimes delete stuff by accident and you have to maybe recover it. So if somebody comes along to, something like the details view, like I want to see the details of this product. If you find it in your database and it's deleted equals true, then you can return a 410 gone response. Or maybe you can say, well, okay, this product was a, I don't know, webcam, because I'm looking at one. This product was a webcam, so I'm going to redirect 303 see other to a search for webcams, or to the webcam category, like the parent category of that product. Maybe that's a good spot to bump the user. And of course, in order to make that work, you have to not delete the record just because it's conceptually deleted. You have to mark it as deleted and deal with that flag when the time comes. Again, maybe there's the reorganization, and this happens. This can happen. Like the best of planning maybe can't predict, like you start getting weird collisions. Like there's a bunch of stuff I wanted URL that starts this way, and then concept for the next product or the next page, I want view and edit and update and increase and decrease. And you end up getting maybe collisions on a URL where you say, okay, all of those are going to have to move here. So you have in your old URL structure some kind of effectively if statement. If it looks like this is an old URL, redirect to the new URL, else continue on and build the page that should be here. And I guess an underlying theme here that I haven't said out loud is URLs shouldn't disappear. And I guess I did say last week, if a URL existed yesterday, I should not get a 404 not found tomorrow. I could get a 410 gone. That's okay. But this this essay that is, it's the one like link in my class notes I don't feel like I have to check every time I go to click on it. I don't think this one's going to change. It's written by what's his name? Tim Berners-Lee, who's the creator of the web, as a sort of, let's nail down like what I think about this. And it's basically URLs. I know it's cool. URIs don't change. I'm just gonna translate that to URLs don't change. And with some like kind of reasonable, like sometimes you do have to reorganize because you just had to. Requirements changed, the site grew and it got bigger, and the URL scheme you started with didn't work. Make sure, at least if you're going to redesign, don't do it every year. Kind of do it right when you do it, and leave redirects in its place. It means keep technology things out of URLs. I don't care what language you use to implement. Probably that includes like .html, but I notice this URL has .html. I did have .html in this URL because it is static and I had that file name there. And there's a couple of examples down here somewhere. Yeah. One is, I had this URL bookmarked. Is my kid's school closed because there's like a snowstorm or whatever? And, he looks outside and it's like, there's a lot of snow out there. But the page that he had bookmarked said, no problems. And it was, they'd actually left the old URL in place, not updated it, but had a new, like if you navigated from the front page of the whatever, you found this whole new page that had updated information. The other one here is like a help URL. Like literally in Microsoft Net Meeting, there was this like, go down to the help menu and get the thing. This took you to a URL, and that URL just stopped working one day. That's probably not cool. All I ask is that URLs work until the end of time. That's all. Easy. Sometimes not easy, but it's the goal you should have in mind. And again, like it's something I try to do. This is one thing about teaching this course. Whenever I actually do web development, I hear myself like speaking from the past saying like, if you're going to let users delete a thing, you should leave a redirect at its place, because otherwise next time you teach Compute 470, you're going to be giving this lecture and you're going to feel bad. And I do. And so at least I tend to be pretty careful about that. Go get a job, come back in a couple semesters, teach this course. You'll be a better web developer for it. Anyway. Okay, something else. I guess I didn't mention this. We saw the headers go by that let this happen, but it turns out different people are different. Different web browsers are different, and different users are different. Different people sitting in front of web browsers are different in various ways. Maybe we want to treat them differently. So it turns out there's some, again, like HTTP headers that are sort of supporting this that almost all developers completely ignore, but shouldn't. So the content negotiation is handled by these accept headers. And again, we saw them, like they flipped across our screen. I think I had this when I was, like this is the example from last week. And they happen in real life. I'll take this tab. So if I open up the developer tools and network pane, and I'll look here, and again, juggling the font size is really tricky. Hopefully you can read that. When my browser made a request, it requested with these headers. So accept text/HTML, whatever that is. So let's come back to those. But there's three of them here. There was a fourth one that we don't seem to need anymore in the modern world. The syntax is the same for all of them, and I hate it, but it's just kind of weird. So the parsing here, like I feel like the semicolon and the comma are parsed not in the order I expect them to be. So this is one, like the list is a comma separated list. This is one thing in the list. Application/HTML semicolon 0.9 is one element of this 4-element list. And the quality is on a scale of 0 to 1. 1 is high quality, 0 is low. These things are implicitly in decreasing order. So A has quality 1 in this list because that's where we start. B has quality 0.9. C has quality 0.9 because it can't be any bigger than the previous one. And then the star is like anything else has quality 0.1. So maybe that's quality like 100% and 10%, like however you want to think about that. But that's the sort of syntax there. It's just a little wacky. The headers that we actually saw were, and I don't remember if this matches or not, but this is roughly what this browser has said is my favorite file types are HTML and XHTML at 100%. Goodness. Other XML documents at 90% goodness, and any other document at 80. And let's see what my browser, what did it actually say? Pretty close to that. So again, like HTML and XHTML are good. XML is a little bit worse. Interesting. That's relatively new in Firefox. You know what I like is WebP images. I like WebP images at 90%. Implicitly here, every other, whoops, oh God. How do I, there it is. Any other image format implicitly, or any other file format at 80%. So there's stuff being communicated here, which is like, if you have if you, the server, have a bunch of different representations of this content, maybe have an HTML version of it and a plain text version of it, the browser has said, I like the HTML better. If you have a WebP image or a PNG image, I like the WebP a little bit better. A lot could be said there. And it turns out even more can be said. Browsers do fiddle with these headers depending on the context. So if the browser was requesting a style sheet, it had a different accept header. So when it was a style sheet request, because it was a link rel equals style sheet, it said, you know what I like about style sheets? I like CSS style sheets. If there's any other style sheet format in the world that you have, I'll take it, I guess. Point one, good. So I guess if there's like an XSLT style sheet, the browser will accept it, but it would be much happier with a CSS style sheet. Or if there's an image here, so again, this is probably an, IMG source equals kind of context. So it knew it was requesting an image. It only said WebPs before everything else. So I prefer a WebP image or other stuff, implicitly just like a little bit less preferred. I think, yeah, there's a different one for fonts too, where it's a style sheet font reference. The browser can say, yeah, I like the whatever WOFF2 font is. I like it at a little bit less than WOFF1, I guess, and not a little bit more than whatever other font format you got. I don't know anything about fonts, but I suppose Firefox likes that format, or it's a little bit more descriptive to it, or whatever. That means that the server could ignore this, right? The server can just say, oh, you like WebP images and other stuff? Here's a PNG. I don't care. Like all I have in the server is a PNG. Here's my PNG image. And that's acceptable. But you can do a little better. Sometimes you have an image that could be a JPEG or could be a WebP. If you haven't come across it, WebP is, a shiny new image format it's better. The compression is better relative to quality. So with a JPEG, you explicitly make that quality trade-off. with other images with lossless compression, it's just like how big is the file afterwards. I was hoping for a comparison there, but anyway, WebP, slightly smaller files for the quality. So if the browser understands it, and not all do, but this is the browser's way to say, I do understand WebP, so if you want to send it, that'll be great. Which means if you're like, I don't know how many sites, I don't want to just go clicking on image sites as I'm recording this. It seems like a recipe for disaster. But if you're creating some kind of site that serves a lot of images, maybe it's worth it. Keep the JPEG and the WebP version of the image around. Have a little if statement that's like, you know, if the browser says they want the WebP, send it to them. We'll save a couple bytes, you know, transfer faster. That'll be great. My site will be better if I can deal with that header and respond appropriately. The next header in the request was accept language. And this is about the user, which is a little trickier, but what's happening here, and I guess what's happening in my browser right now is I'm sending just English. I guess I have my browser set. Where are these things? Preferences. And I feel like they keep moving this thing approximately once every time I have to go look for it. It moves somewhere. Is it general? There it is. Okay. So my my language is somehow set to this at the moment. Oh, there we go. That's a good, sure. Oh God, it's going to change my browser language, isn't it? Great. So this page that I loaded a few seconds ago was in English. If I reload it, oh, we're not going to work? Or maybe they don't have a, whatever I just chose, Finnish translation. Let's see about that. It could be that I'm not. Wait, am I actually affecting this? So, oh, I'm not. That setting isn't actually changing my language preference in the header. Oh, I have to restart. It's right there. I'm not going to restart. That seems like that just seems like a recipe for disaster in the middle of a lecture. I'm going to stay with that. What would have happened here is if I reloaded there, I guess I can restart my browser to get the language setting, but this would have magically changed to German. The URL didn't change. This URL is just capable of responding with different language versions depending on what the user says they want. That's really nice. And so many websites, even if they're multilingual websites, don't do this because, well, partially because it's unreliable. It's a setting about a person that's generally automatic. I'm willing to bet there are people here. Probably that thing was set to English because my browser install or my operating system installation is in English. And I'm willing to bet there's people here who speak more than one language or read technically more than one language and have never changed that browser setting. You can. Whoops. Let's not start getting other languages. Most users don't bother. Most users have just the one language that is probably their OS default language. So relying on it is sketchy. That means that you probably have to let the user override. And in fact, on the Debian website over here, again, it's in English. But if I scroll down here, there's the, you know what, if you're seeing the English version, but it's because you would prefer the Spanish version, but your browser set wrong, there's this manual, like, no, I want to manually update my language preference and get there. God, this is one that irritates me so much. Anybody that's ever traveled, like if you go to Google anywhere in the world, they automatically redirect you to the localized version, to like, is it google.hk or whatever it is, com.hk. And somehow if you happen to be in this physical part of the world, even though my browser is sending an accept header that says what language I want, Google, I haven't tested it this month, but until very recently at least, it would just say, oh, you probably a traditional Chinese reader because you're coming to the .hk site. And even if you try to type .ca, it sends you back to the one where you physically located and gives you the local language. Even though my Google account has a language preference and my browser has a language preference, they ignore it. I hate it. Anyway, on the server side, like if you're creating a site, this is one of those things that's like conceptually very, very easy, and in practice, very, very hard. All you have to do is find every string that's visible to the user anywhere in your entire application and wrap it up in like a translation tool. Like, so this function that's being imported with a really short name just so it's easy to type, you just have to wrap it around every single string and then go and make a translation file that is every single string translated into the appropriate local language. Maybe you can say the default is English. I'll have English strings in my code, but then, we'll have the German translator go through and rewrite every single user visible string in German. And easy to say, I bet there's a lot of strings in your code. And by the way, somewhere here is, so that's like in this example, that's for Python code. Somewhere here, there's a, if you're doing this in an HTML template, there's another, like, you somehow have to mark the string as here's a thing that is translatable and should be translated. Go look it up in the language file according to whatever rules and display the right one to the user. No problem. So the third header that's there, that again, the browser was sending, these have always been sent, is the accept encoding header, which I guess it's technically the right word. It's not character encoding. That thing that I talked about where I said character encoding, this is a different encoding. This is, I have some bytes and I want to give them to you. Is there some way I can, well, frankly, compress them? Is there some way I can take these bytes, encode them that you can decode at the other end? The real reason to do that is compression. So this seems to be, and I think this is the one I just saw in Firefox. It still matches my slides. And there's this little communication was, dear web server, as I make my request, if you would like to send back the response gzip compressed, that would be fine because I know how to ungzip something when it comes back to me. Or deflate compression, or Brotli, I think, or I don't even remember what SDCH is. Both sort of newer compression methods. Brotli, I think, specifically for web content. Somehow it's really good at HTML or something. But that's nice. And this, by the way, has been happening. When can I please just reload the page? Okay, there we go. This page is 14 point something kilobytes. What was transferred was 3 point something kilobytes. And that's because it was compressed on the way. And I bet if I look, well, the request was made with, I accepted gzip encoding, and the response came back with gzip encoding. So the headers came to the user, and I guess I can probably, I think it's -H, or maybe that's wget. Anyway, let's find out. If I make the request with that header, so I think when I do a curl request, I think it's -H that injects an extra header into the request. And yep. So the response comes back with content encoding. So the server tells me on the browser, just so you know, the headers didn't change. Just so you know, when you get to the content here, down to that message body, it's gzip encoded. And then this is presumably 3 and change kilobytes of gzip compressed content that it expands to be HTML. That's really nice. And like, if you look at what's been happening here, like on this page, 14 kilobytes became 3. This style sheet apparently compressed really, really well. Style sheets are repetitive. Apparently this style sheet is apparently extremely repetitive, compressed very, very well. But all of these text-based things are compressing to like 1/3 or so of their original size, sometimes even a little better than that. You won't see that for images, like a JPEG image. If you gzip compress it, you're not gaining anything. There's no point in compressing it. But yeah, a lot of these files I saved a lot. And in fact, even though like I hit Control-Shift-R to reload, like ignore the cache and reload everything, if you can read it down at the bottom here, this is it's 540 kilobytes of stuff. I transferred 190 kilobytes over the wire. So 190 kilobytes expanded to 540 or so. That was great. Like, the gzip compression saved a lot of bytes over the network. So again, we have this question of how do we make it go? How do we make this actually happen? For static content, well, the thing that does the static content is going to have to do it, and that's the web server. So for Nginx, you sort of say, yeah, please gzip. You say some types, because like I said, it doesn't make sense to look at a JPEG or a PNG image and try to gzip it. That's going to be a waste of time. So the directive here is, if you have plain text or HTML, or you probably want style sheets and SVG images in your list, and they're more than 1,000 bytes, it's probably not worth, if you have some tiny little style sheet that's like 2 lines for some reason, it doesn't make sense to gzip that. You're not going to get a smaller result out the other side. And that's it. It's like a couple lines of config, and all of a sudden your site is a little faster. For dynamic content, well, I guess I'll say 2 things here. For dynamic content, and if I pick a dynamic page, so again, I happen to know this one is dynamically generated. I don't know what's happening. So I'm just looking over here. This was a 200 OK. Even though I hit Control-Shift-R, these things were taken where the cache was used. And just for the demo, it seems like if I hit it a couple times or something, I don't know. Anyway, yeah, the 3rd time I hit Control-Shift-R, or 4th time, it actually ignored the cache and actually fetched everything. I don't know. Usually I don't want that. Like, that is a weird thing to want, but I want it for the demo. Yeah, this page was 8 or so kilobytes, much smaller. Again, these style sheets and JavaScript, they're text, they're repetitive, so they compress well. Is there anything that didn't compress? Not really. So it's not an image heavy page. I guess there are these 2 PNG images that are part of the SFU template. It was just under 29 kilobytes and just over 29 kilobytes were transferred. I wonder if that's just, yeah, it wasn't encoded. That's probably just like rounding off to the size of the network packet or something. Or maybe it's including the HTTP headers. This is the file size. This is how many bytes it took to transfer it. So yeah, maybe the difference there on those is just we had HTTP headers that we count in this column. That would be my guess. So these are all roughly the same size. The fonts and the PNGs, the things that are pre-compressed effectively, right? Like, that file format is inherently compressed. The JavaScript and the CSS and the HTML benefit a lot from that. For dynamic content in general, remember how much static content there is. Most of those bytes were CSS and JavaScript. They're just coming off a disk. So it might not be worth it to worry about compression for your dynamic HTML just because it's such a small fraction of the bytes. So maybe that's the first one. Maybe don't worry too much about it. But that being said, a lot of frameworks have some version of this where you can effectively just turn it on and say, yeah, when pages go out, have a look, and it's, if the response is HTML and kind of bigger than a certain size, just go ahead and compress it. And so that one was Python and Django. This is JavaScript and Express.js. They really buried the lead here. But what's happening is, like you get to have a little callback of like, should it compress or not? And again, you could put in here, I suppose, like if the file is too small, don't worry about it or something. But mostly you just turn it on. Turn on this middleware that when the response is coming back, could compress it if it feels like it. Again, if the CPU time to do the compression is worth it relative to the savings of less transfer over the network, that'll be awesome. Okay, so that's the end of this slide deck and probably a good spot for a break. So we'll have 9 or so minutes here, and we'll come back to whatever 9 minutes is from now. Yeah, have a good break. See you in a few minutes. Enjoy your dinner.